only within the range of 50 megahertz. So I'm giving here as 100 megahertz. So now transmission gain I give here 10. Antenna TX1. So now this is the rate of my USRP, which means I can say it as a IQ conversion rate. So this is the sampling rate of the signal. What do I transmit? Only within the range of, so I can mention 100K signals. I'll say at a 10K rate. So now what do I do? It is when I transmit. So if you see, as per my LED indications, A is meant for transmission. A is meant for transmission. So what do I do is in my screen, I'll just pin this one. So if you see there, I don't know whether it is visible or what. I'll just go near to it. So this is the USRP what we have. I'll just focus little. Yeah, I think USRP is visible. So now if you see, the A element is not glowing, A LED is not glowing. F is for power. Is a transmitter. Okay. So this is it is of 2K. So I'll zoom the cycles also. So now I continuously transmit 3, 4, 5. So whatever transmissions I define here in it, doing. So when I stop my code, what happens is that A LED would have been stopped by this time. So I stop my program. So now I change this to 10K. It will not work out. It will not change because I am not running my program. So if you see here, I have defined what data I am transmitting here. So I supposed to receive the same data if I run my receiver part. So I'll go to my receiver part. So there I define the same portions there. So here I'm receiving at 915 megahertz. So here I'm sampling at the rate of 200K kilosamples. So I run here. USRP C is glowing, which means it is receiving data. Continuously I'm receiving data. I am not transmitting anything so far. So now I do the transmission. It is a 10K, 20K signal. I'll say it is 3K, 6K somewhere there. So now I have a transmitter as well as I have a receiver, but the signals won't be proper because the reason is I'm showing you for full duplex. Excuse me. Here I'm receiving through an antenna called as RX2. Here I'm transmitting through a section called a TX1. So far I don't have any issues with it. The problem here, why I'm not getting the same sine wave here is, the carrier frequency. I am transmitting at 915 megahertz. I'm receiving, I'm transmitting at 100 megahertz. I'm receiving at 915 megahertz, which means I'm working on somewhere on 10. I'm trying to expect a result on somewhere on 900. It is not possible. So what should I do is, I have to stop my transmission. I'll change this carrier frequency as 915 carrier frequency. I do transmit here, automatically you will get the data there. Do you see I got the data there? So I have given 6, but the signals are proper. Signals are not proper because of the reason I am not transmitting at the rate of 200k. So now I got 6 here. So there I am trying to generate more number of samples. Here I am trying to generate less number of samples, so I will not get my signals proper. So now I have my signals at 6k here. Changes there, right? So where I have in it. So now I make it as 7.5k. So it lies within the range of 7.5k there. So easily we can take our data. So this is what it is. So this is your signed data, what you are transmitting. I say stop. I'll not get any data there. So this is the actual data. We are not doing any changes there. We are not doing any changes there. So if you see in it, the signals rating we are acquiring there in it. Yes, whatever we are generating, we are acquiring there in it. So I don't know how many of you have seen disturbances clearly. Show your disturbance here. Do you see in it? When I come somewhere, these antennas, what happens here is, you could see the disturbance over received signal. I'm wearing this transmitter. For example, if I place any obstacle there, so if I insert a mobile phone, if I make, do you see now what is the interference? Do you see there is a blink? This is because of my data is on. Take it out. I'll not have. When I keep my mobile phone near, do you see the interference? So far it is quite okay. Now the levels are too low. If I want to prove you things here, I'll stop transmission. I stop transmission. I'm acquiring at a gain 10. Here also I'm acquiring at a gain 10 minus 0.6 to 0.6 here, zero point 0.5 which I'm transmitting. I'm not getting 0.5 here. Yes, I'm not getting 0.5 here. Think what is the transmit? I'm getting only 0.1. So I remove this auto scale. I'll keep it as 0.5 minus 0.6. I'll keep it as 0.6. I'll say 0.6. So I just remove my mobile phone out of it. So now, if you see when we try to keep things there, do you see the changes on the top limit? So when I keep my mobile phone in it, so now it is varying very much. So simple mobile phone interference will be too much for you there. So if I get a call, obviously it is there. Yes. Uh, if I want to give you a live presentations, ma'am, the organizer, ma'am, do you have my mobile numbers? So this would be something. That's the reason when they say when you work on any RF elements particularly, so you should not carry, should not have what tube light interference, no electromagnetic signal interferences. This is what these reasons, because they are subject to what to say. So this will I could say it is, this will affect your working. This will affect your quality accuracy there in it. Reason we are saying it, no electromagnetic devices in. So now are you all clear now? So how things are happening? Because so far I have not shown you my block diagram. I'll open my block diagram. So here if you see, I open a session, I configure my signal, I transmit my data. Here I have two sine waveforms. So to define my amplitude and phase angles, I'm define my sampling frequency. I'll converted, I'll giving over there. So this is how I'm working over there for transmitting and receiving a part. So am I clear now? So do you understand? I think now you all got about why I have used these things in. So now if you say this is for reception, I'll open my receiver code, then I'll show you this. So now do you see I have an open USRP session, configure USRP, initiate, started, acquire data, fetch, abort. I start what we have over here. Initialize, configure, start, read or write, stop and close. This is the sequence we need to follow if you want to configure your USRP there. Then if you see, we need to define which device it is, what is the IQ rate, conversions rate. So what is the carrier frequency which you are going to transmit your signal, which antenna you are going to use to receive or transmit your data, what is the transmission gain, so what is the reception gain, and how many number of samples you are going to define for your transmission or reception. Then I need to define which device. How will I identify? I'll use a configuration to define what is the IQ rate. So what is the bandwidth of my device? Based on that, I will define. If my hardware is of 20 kilohertz bandwidth, maximum 200K. If my hardware has 100 megahertz bandwidth, I'll go with 1 megahertz. 100 kilohertz bandwidth, I'll go with the 1 megahertz. Which you need to define your SSB signal. My carrier frequency remains this. So this USRP is the one which is going to convert it and give it to the converter. Will do that conversion factors there. So now this will be whether it is your DSB SC signal or DSB signal. I can define what to transmit and receive here. Only thing I need to, that's it. So now here I need to define what is the transmission gain. I need to go. So this hardware can go up to 36 dB. So here I have given only up to 10 dB per day. Even if I still I can receive the data properly because they are very close. And number of samples, you all understand why we need to give more number of samples so that we'll get more number of informations into my signal. So this number of samples are too much, then your fetch time also will be too much, which means reading signals will be take more time. If the number of samples are less, then this reading signals will be very less. So taking time, every time it will continuously acquire. So internet will have a buffer to store this and take it out. So this is the USRP programming part. So now what I'll do is we'll try to do this from the scratch. We'll try to show you how we can code it over there. So I'll use a communication design suite so that we all understand how these things will work. So now I'll close LabVIEW part. I'll open Com suite, communication design suite. So I'll open LabG next generation programming. So I think it's almost one modules are working or how this can help us or anything. Has any, are you guys there? No, so far. Excuse me. So give me some time, let it open, so we'll continue coding part. Yeah. These are the programs what we have done. So, if you see in it, can you please move on? Thanks, ma'am. Thank you. So now, if you see here, this is what we have done on our Thursday. We have defined what kind of signals to be transmitted. We apply F50. So all these changes we have seen. We created a control. So and we have seen how our basic front panels has to be, and we try to generate some logics in it, and we'll try to make it as a signal. And how our filters will work in it. Then we gone for a simple modulation scheme. So just multiplying two elements. So combining all these values, how we can get them together. And we went for modulation scheme factors. We defined input signal, modulate, up convert. So we use our icon one by one. And we gone for sampling rate FFTs separately we did. Then we'll see about USRP now. So what I do it is I'll create a new VA. So save all. So now file, I'll create a new project, or I can create a new VA itself. So say so now what I'll do it is, so we have to do a program for hardware, right? So we need a hardware related icons and hardware related programs here. So where do we have hardware? So we have control, we have Boolean control, where we get this hardware related controls. So now what I do it is I go to my block diagram. So where I have this hardware interfaces. So far whatever we have done is we have used our while loop, for loop, AND gate, OR gate logic. Yes, some numeric functions, signal processing, analysis, generation, transform, measurements. Whereas here we are going to work on hardware basis. So we are going to work on hardware interfaces. So I'll go for hardware interface. So I define here what kind of DAC I'm going to use. So whether I'm going to work on a DAC card or I'm going to work on a wireless design prototype or I'm going to work on FPGA based USRPs. So what I'm going to work? So I'm going to work on wireless devices. I'm going to design something. I'm going to test something. So I'll go for a USRP. So in USRP, whether I need to go for a transmitter or receiver. So what do I do it is I'll go for a transmitter section now. So in transmitter, do you see then open, configure, write, close. So I'll just take the icon, this icon, what device name I need to give. So I right click, create a control. So I got the device name. So if you see in my front panel, I got the unused icon. So I have the device name. So I keep here. So this is the device name. So in this device, which device is being connected? Check 192.168.10.2 is there. Yes, I have chosen. See, I'm going one by one so that you all can understand how this coding has been made. So now next I'll go for USRP, then I'll go for configure signal. I keep this icon here. So this sequence I have to follow. So after this icon, so I connect this interface over there. So now I need to say what is the IQ rate. So I create an IQ rate. Then I define so I take a transmission gain. So I define what are the things I need. So I need to have the I transmission gain. It is either 100 or 10. Let rate for side. So here I to jet in the range of so this now what is what after so I need what elements you can now I need to do transmission. Write data. I need to write a data here. One perception. So I have an RF channel. So now I took a single channel. So whether it is a complex double or wave, I give it a wave. So now I do this input and this is sequence. So transmission. So in this transmission, I need to define what are all the informations I need to go for. So what are all the informations I need to go for? Here also, so I give the data there. What data I'm supposed to give? I need to provide the waveform data here so that it will transmit. So now what we are doing is for data signal pushing. So the same one I'm going to wave. So this is going to be the same waveform. I'll have one more copy. I paste here. So this is a sine waveform. So an IQ data. What I have to give is one should have a phase angle constant 0. So what should have phase angle? Now if you see this is a I waveform, this is a quadrature waveform. So there is any value. So I create a constant. So I want so this is amplitude, this is the phase. So here I do the same amplitude because both the signals have the same amplitude. Both the signals should have the same frequency as well. So I can control so that this can convert. So elements. So what do I control the same frequency there? They have two frequency. So this is of I. So this is Q. phase has a 90 degree, and phase has a 90 degree. So now here I have a sampling rate. I take here. So now what do? I will connect this sample here. I'll just so means the so now what I have to real imagine it. So you go for mathematics or some operations, anything there. So I have this conversions. No, these are all number conversions. Split number, join, left, right. Complex. Yeah. So do you see here? I have so this here. So this is real data. It's not possible because I need to cut into a waveform and do a type. So I cluster base. So this y the same I use here. This is my so I have real data. I have an image data. So this I have so this so this is so these two I have combined. So now this information I have to give over there. Now this is accepted. Here it was not accepted. Now it. So I now change it to be a complex complex. So it is not there. So this I keep so I have start open transmit configure transmit. Then what I do is I have to go for